Hello everyone, Dr. Alan Mandell here. Welcome back to my channel, Science of Healing. What would happen if you stopped eating sugar for just 14 days? Not forever, not for a year, just 2 weeks. Your body would begin to change in ways most people never expect. Hi, I'm Dr. Alan Mandell. Today we're going to break down exactly what happens inside your body, from your brain to your heart to your gut, when you remove added sugar for 14 days. And I promise you, the science behind this is powerful. Let's start with what sugar actually does. 14 days, that's all we're talking about. Not a year, not a lifetime, just 14 days without added sugar. And your body begins a transformation most people never believe is possible. The human body is not fragile. It is adaptive. It is intelligent. And the moment you stop flooding it with added sugars, powerful biological systems begin recalibrating almost immediately. Within hours of removing added sugar, your blood glucose levels begin to stabilize. Instead of dramatic spikes followed by crushing crashes, your bloodstream experiences something rare in modern life: balance. Research shows that repeated glucose spikes trigger excessive insulin release, and over time this drives insulin resistance, the root mechanism behind type 2 diabetes, metabolic syndrome, and stubborn belly fat. When sugar is removed, insulin demand drops, and that is where healing begins. By the end of the first 48 hours, insulin levels are already lower than they've been in months for many people. Lower insulin is not just about diabetes risk. Insulin is a fat storage hormone. When it remains elevated, your body is locked in storage mode. When it falls, your body finally receives the signal to unlock stored fat and begin burning it for fuel. This metabolic shift is called improved metabolic flexibility, the ability to switch from burning sugar to burning fat. Studies in metabolic physiology show that even short-term reductions in refined carbohydrates improve this flexibility. That means your body becomes more efficient, more resilient, and more stable. Around day 3, something profound begins happening inside your liver. Excess added sugar, especially fructose, is processed almost entirely in the liver. When intake is high, the liver converts much of it into fat through a process called de novo lipogenesis. This contributes directly to non-alcoholic fatty liver disease, a condition now affecting up to 25% of adults globally. But research shows that within just 7 to 10 days of reducing added sugar, liver fat can decrease significantly. Liver enzyme markers begin improving. The organ responsible for detoxification, metabolism, and nutrient processing finally gets relief. And then there is inflammation. Chronic high sugar intake has been shown to elevate inflammatory cytokines, small proteins that drive systemic inflammation. Inflammation is not just about joint pain. It is the underlying fire behind cardiovascular disease, neurodegeneration, autoimmune disorders, and accelerated aging. When added sugar is removed, inflammatory markers such as CRP often begin declining within days. That silent internal fire starts cooling. By the end of the first week, many people notice something unexpected: steady energy, no mid-afternoon crash, no desperate need for caffeine or sweets. This is not psychological, it is biochemical. When blood sugar stabilizes, cortisol, your stress hormone, also becomes more balanced. The body no longer swings between emergency highs and exhausting lows. The adrenal glands stop being pushed into overdrive. At the cellular level, insulin receptors begin becoming more sensitive again. Research on dietary interventions shows that reducing refined sugars improves insulin receptor responsiveness in as little as 2 weeks. This means glucose enters your cells more efficiently. Your pancreas does not have to overproduce insulin. The metabolic burden decreases. And then something even more remarkable happens. Your waistline begins to change. Visceral fat, the dangerous fat stored around your abdominal organs, is strongly driven by high insulin levels. As insulin drops and fat burning increases, this deep inflammatory fat begins shrinking. This is not cosmetic weight loss. This is risk reduction. Visceral fat is directly linked to heart disease, stroke, and cognitive decline. Losing even a small percentage dramatically improves long-term health outcomes. By day 10, many people report clearer thinking. This is not imagination. High blood sugar variability has been associated with impaired cognitive performance and reduced brain-derived neurotrophic factor, BDNF, a protein essential for learning and memory. Stabilizing glucose allows the brain to function without constant metabolic stress. The fog lifts, focus sharpens, mood stabilizes. And then there is the gut. Excess sugar feeds harmful bacteria and yeast strains, contributing to dysbiosis and imbalance in gut microbiota. This imbalance has been linked to bloating, weakened immunity, and even anxiety. When added sugar is removed, beneficial bacteria gain ground. The gut lining becomes less inflamed. Considering that nearly 70% of the immune system resides in the gut, this shift has systemic consequences. Immunity strengthens, digestion improves. Sleep often improves by the second week. Blood sugar swings at night can trigger cortisol spikes, waking you abruptly or preventing deep restorative sleep. When glucose stabilizes, sleep cycles become more consistent. Growth hormone release improves, cellular repair accelerates, recovery deepens, and here is the most underestimated transformation of all. Your taste buds reset. Studies on sensory adaptation show that repeated exposure to high-intensity sweetness dulls taste receptor sensitivity. When added sugars are removed for approximately 2 weeks, taste receptors regain sensitivity. Natural foods begin tasting sweeter. An apple becomes satisfying. Berries taste indulgent. The brain no longer demands extreme stimulation. This is how cravings weaken. Dopamine pathways, previously overstimulated by high sugar intake, begin recalibrating. The constant reward-seeking loop quiets. You regain control over your impulses instead of being controlled by them. By the end of 14 days, your body is not on a diet. It is functioning the way it was designed to function. Insulin sensitivity improves, inflammation decreases, liver fat reduces, visceral fat begins shrinking, energy stabilizes, mental clarity strengthens, sleep deepens, gut bacteria rebalance, all in 14 days. This is not magic, it is physiology. The human body has an extraordinary capacity to repair when you remove what is overwhelming it. Modern diets contain unprecedented amounts of hidden sugars in processed foods, beverages, sauces, and snacks. When you remove that constant assault, the body does not struggle. It responds quickly, powerfully, and perhaps the most empowering truth is this: you do not need perfection. You need interruption. Interrupt the cycle for 14 days, and you interrupt the metabolic cascade that leads to disease. 14 days without added sugar is not deprivation. It is liberation at the cellular level. Your pancreas breathes easier. Your liver unloads stored fat. Your brain stabilizes. Your hormones rebalance. And when you look in the mirror after 2 weeks, what you may notice first is not just a flatter abdomen or clearer skin, but a feeling of control. Control over cravings, control over energy, control over your health trajectory. 14 days. The reset begins the moment you stop feeding the problem. Sugar does not just affect your weight, it reaches far deeper into your brain, your liver, and the very ecosystem living inside your gut. Every time you consume added sugar, a biochemical chain reaction begins within minutes. In your brain, sugar stimulates the release of dopamine, the powerful neurotransmitter associated with pleasure and reward. Studies using brain imaging have shown that highly refined sugars activate the same reward pathways involved in addictive behaviors. The more frequently this pathway is triggered, the more the brain adapts, demanding stronger stimulation to feel the same reward. What once tasted sweet becomes normal. What once satisfied becomes insufficient. Cravings intensify not because of weak willpower, but because of altered neurochemistry. Over time, excessive sugar intake can disrupt dopamine receptor sensitivity. Research suggests that repeated overstimulation may blunt the brain's reward response, contributing to mood instability, irritability, and even symptoms associated with depression. When blood sugar rises rapidly and then crashes, the brain, which relies heavily on glucose for fuel, experiences a metabolic roller coaster. That crash triggers cortisol and adrenaline, stress hormones designed for survival. The result is anxiety, shakiness, mental fog, and an urgent desire for more sugar. The cycle repeats. But the brain consequences do not end with mood. Chronic high sugar intake has been linked to reduced levels of brain-derived neurotrophic factor, or BDNF, a protein essential for learning, memory formation, and neuroplasticity. Lower BDNF levels are associated with cognitive decline and increased risk of neurodegenerative disorders. Some researchers now refer to Alzheimer's disease as type 3 diabetes because of the strong association between insulin resistance and impaired brain glucose metabolism. When insulin signaling becomes dysfunctional, neurons struggle to access energy efficiently. The result is inflammation, oxidative stress, and progressive cognitive damage. Then there is the liver, the metabolic command center of the body. Unlike glucose, which can be used by nearly every cell, fructose, a major component of added sugar and high fructose corn syrup, is metabolized primarily in the liver. When consumed in excess, fructose overwhelms liver cells and is converted into fat through a process called de novo lipogenesis. This newly formed fat accumulates within liver tissue, contributing to non-alcoholic fatty liver disease, a condition that now affects an estimated 1 in 4 adults worldwide. Fatty liver is not harmless. It increases the risk of insulin resistance, systemic inflammation, fibrosis, and eventually cirrhosis. Even more concerning, fatty liver significantly elevates the risk of cardiovascular disease. Studies show that individuals with non-alcoholic fatty liver disease are more likely to develop heart attacks and strokes, even if they are not visibly overweight. The damage is silent. It progresses quietly, often without symptoms, until laboratory tests reveal elevated liver enzymes or imaging shows fat infiltration. Excess sugar also drives the production of advanced glycation end products, harmful compounds formed when sugar molecules bind to proteins and fats in the bloodstream. These compounds promote oxidative stress and stiffen blood vessels, increasing blood pressure and damaging delicate tissues, including those in the brain and heart. Glycation accelerates aging at the cellular level. It contributes to wrinkles externally and vascular damage internally. Now consider the gut, home to trillions of microorganisms that influence digestion, immunity, metabolism, and even mood. High sugar intake alters the delicate balance of gut microbiota. Harmful bacteria and yeast thrive on simple sugars, while beneficial strains that produce anti-inflammatory compounds struggle to compete. This imbalance, known as dysbiosis, increases intestinal permeability, sometimes referred to as leaky gut. When the intestinal barrier becomes compromised, bacterial toxins can enter the bloodstream, triggering systemic inflammation. Inflammation does not remain localized. It travels. It influences joints, blood vessels, brain tissue, and immune cells. Emerging research links gut dysbiosis to autoimmune disorders, obesity, anxiety, and depression. The gut-brain axis, a direct communication network between your digestive system and central nervous system, means that what happens in your intestines does not stay there. It shapes your emotional and cognitive health. Excess sugar also feeds Candida and other opportunistic yeast species, contributing to bloating, gas, and digestive discomfort. For many individuals, chronic sugar consumption becomes a self-perpetuating cycle. Cravings fuel imbalance, imbalance fuels cravings. The immune system is deeply intertwined with this process. Nearly 70% of immune tissue resides along the gut lining. When sugar-driven inflammation persists, immune regulation weakens. Studies have shown that consuming high amounts of sugar can temporarily suppress immune cell activity, reducing the body's ability to respond effectively to pathogens. In a world where immune resilience is critical, this suppression carries serious implications, and the heart does not escape unscathed. Elevated sugar intake is associated with increased triglycerides, reduced HDL cholesterol, and heightened inflammatory markers, all significant risk factors for cardiovascular disease. One long-term study found that individuals consuming high levels of added sugar had a significantly increased risk of dying from heart disease compared to those who consumed lower amounts. The mechanism is not just about calories, it is about metabolic disruption, insulin resistance, and vascular inflammation. The most alarming truth is that many people consuming excessive sugar do not appear outwardly unhealthy. They may not be severely overweight, they may exercise, yet internally, insulin resistance may be progressing, liver fat may be accumulating, inflammation may be simmering. The damage is often invisible until it becomes clinical, but there is a powerful counterpoint. When added sugar intake is reduced, these systems begin to recalibrate. Dopamine signaling stabilizes. Blood sugar variability decreases. Liver fat can decline within weeks. Gut microbiota diversity improves. Inflammatory markers fall. Insulin sensitivity increases. The brain regains clarity. The liver regains efficiency. The gut regains balance. This is not fear-based messaging, it is biology. The human body is remarkably resilient when given the opportunity to recover. Removing excess added sugar is not about deprivation, it is about eliminating a metabolic stressor that disrupts multiple organ systems simultaneously. Your brain was designed for stable fuel, not constant spikes. Your liver was designed for moderation, not overload. Your gut was designed for diversity, not domination by sugar-feeding microbes. When sugar consumption becomes chronic and excessive, it quietly undermines these systems. When it is reduced, they respond with measurable improvement. The transformation does not require perfection. It requires awareness and action, because sugar does not only influence the number on a scale, it influences how clearly you think, how steadily you feel, how efficiently your liver works, how balanced your gut ecosystem remains, how strong your immune defenses stand. The question is not whether sugar affects your body. The science is clear, it does. The real question is how long you allow it to continue shaping your brain, your liver, and your gut before you decide to interrupt the cycle. Small daily decisions seem harmless in the moment. A spoonful of sugar in your coffee, a packaged snack between meals, a sweetened drink to get through the afternoon. But biology does not measure habits by intention. It measures them by repetition. And when you begin making small, strategic changes each day, the body responds with powerful biological shifts that can transform your health trajectory in ways most people never imagine. Eliminating added sugar is not a dramatic act. It is a quiet interruption. And yet, research shows that even modest reductions in added sugar intake can significantly improve insulin sensitivity within weeks. Insulin is not just a blood sugar hormone. It is a master regulator of fat storage, inflammation, and metabolic signaling. When you lower added sugar and reduce insulin spikes, you are not simply cutting calories. You are altering hormonal instructions at the cellular level. One of the most powerful daily changes you can make is increasing protein intake. Protein stimulates the release of satiety hormones like peptide YY and GLP-1, which signal fullness to the brain. Studies show that higher protein meals reduce overall caloric intake and stabilize blood sugar more effectively than high carbohydrate meals. When protein intake increases, cravings often decrease naturally, not through willpower, but through physiology. Pairing protein with healthy fats amplifies this effect. Foods rich in monounsaturated and omega-3 fatty acids, such as olive oil, nuts, seeds, eggs, and fatty fish, slow gastric emptying and blunt glucose spikes. Research published in metabolic journals demonstrates that balanced macronutrient meals reduce post-meal glucose variability, a key driver of oxidative stress and vascular damage. These are not cosmetic changes. These are protective shifts occurring inside blood vessels and organs. Fiber is another daily tool with extraordinary power. Soluble fiber forms a gel-like substance in the digestive tract, slowing glucose absorption and feeding beneficial gut bacteria. When gut bacteria ferment fiber, they produce short-chain fatty acids like butyrate, compounds known to reduce inflammation, strengthen the intestinal barrier, and improve insulin sensitivity. Increasing fiber intake by even 10 to 15 grams per day has been associated with measurable reductions in cardiovascular risk. A simple habit, adding vegetables, legumes, chia seeds, or flax seeds, can reshape the microbial environment inside your body. Hydration, often overlooked, plays a critical metabolic role. When insulin levels fall due to reduced sugar intake, the kidneys excrete excess sodium and water. This natural diuretic effect can lead to rapid fluid shifts in the first week. Maintaining proper hydration supports blood volume, electrolyte balance, and cellular function. Even mild dehydration has been shown to impair cognitive performance and elevate cortisol levels. A glass of water is not trivial. It is biochemical support. Replacing sugary beverages with water or unsweetened alternatives eliminates one of the largest sources of added sugar in modern diets. Sugary drinks deliver glucose and fructose rapidly into the bloodstream without fiber to slow absorption. This rapid delivery overwhelms metabolic pathways and contributes directly to insulin resistance and fatty liver accumulation. Removing them alone can reduce daily sugar intake dramatically, often without changing any other food. As these small changes accumulate, the body's response becomes visible. Within days, blood sugar variability decreases. Continuous glucose monitoring studies show that individuals who reduce refined carbohydrate intake experience fewer extreme glucose peaks and crashes. This stability reduces oxidative stress, a key factor in aging and chronic disease progression. Stable blood sugar also influences the brain. Large glucose fluctuations have been associated with impaired attention and memory performance. When variability decreases, mental clarity often improves. Mood stabilizes. The constant biochemical turbulence quiets. Waist circumference begins to shift not because of starvation, but because insulin levels are lower and fat oxidation increases. Visceral fat, the metabolically dangerous fat surrounding internal organs, responds particularly well to improved insulin sensitivity. Research indicates that even modest dietary improvements can reduce visceral fat within weeks, lowering cardiovascular risk markers significantly. Sleep improves as well. Blood sugar spikes late in the evening can trigger cortisol release during the night, fragmenting sleep cycles. Stabilizing glucose reduces these stress signals. Deep sleep enhances growth hormone secretion, tissue repair, immune function, and metabolic recovery. One small daily choice, skipping late-night sweets, can cascade into hormonal balance overnight. Taste perception changes quietly but profoundly. When exposure to high levels of added sugar decreases, taste receptors regain sensitivity. Natural foods begin tasting sweeter. The brain's reward system recalibrates. What once required extreme sweetness to satisfy now requires far less. This sensory reset weakens the psychological grip of sugar. Consistency, not intensity, drives this transformation. A single healthy meal will not reverse insulin resistance, but repeated daily shifts alter gene expression through mechanisms known as epigenetic modulation. Nutritional patterns influence which genes are activated or silenced, particularly those involved in inflammation and metabolism. This means your daily food choices communicate instructions to your DNA. Even markers of systemic inflammation respond. C-reactive protein, a common inflammatory marker linked to cardiovascular risk, has been shown to decline when refined sugars are reduced and whole foods increase. Lower inflammation reduces strain on blood vessels, joints, and neural tissue. The internal environment becomes less hostile, more balanced. And perhaps most empowering of all, these shifts reinforce themselves. Stable blood sugar reduces cravings. Reduced cravings make healthier choices easier. Easier choices create further stability. The cycle that once fueled metabolic dysfunction begins reversing direction. This is not about perfection, it is about pattern interruption. Removing added sugars, increasing protein and fiber, choosing whole foods, staying hydrated, these are simple decisions. But repeated daily, they alter hormones, microbial balance, inflammatory pathways, and brain chemistry. Within 2 weeks, many individuals report steady energy throughout the day, fewer mood swings, reduced bloating, improved digestion, clearer skin, better sleep, a subtle but undeniable sense of control. The scale may move modestly, but inside, metabolic systems are recalibrating in ways far more significant than numbers. Insulin sensitivity improves, liver fat declines, visceral fat begins shrinking, inflammatory signaling decreases, dopamine pathways stabilize. These are not temporary changes, they are foundational adjustments that shift the direction of long-term health. Chronic disease does not appear overnight. It develops from repeated daily patterns, and health is restored the same way, through repeated daily corrections. Small choices seem insignificant in isolation, but biology compounds them. Every meal is a message. Every beverage is a signal. Every snack is an instruction. When those instructions change, the body listens. And when the body listens, it responds with measurable, powerful, protective transformation.